I'm on the air. So, all right. Well, good evening, everyone, and good morning and good afternoon to those who might be checking in from other parts of the world. Welcome to the June 2024 Java User Group meeting, the Garden State Java User Group meeting, of course. So we're very happy to have Mark Nelson from Oracle here. I'll introduce him in a minute. And of course, we do our usual spiel. We have our agenda. We're going to thank our sponsors, talk about what's new, and introduce Mark. And then after his presentation, we do the usual, hey, what's coming up? So with that in mind, our silver sponsor is Azure. And, they have a downstream distribution of OpenJDK with the coordinated restore at checkpoint, AKA crack. I'll spare you all the joke on that. Our partner is DevNexus. This year's conference was 2 months ago. It was awesome. It was my first time there. Not only did I get to attend, I also got to present. So that is, yeah. Oh, all right. Sorry, Barry. And then our per meeting sponsors are JetBrains. They give us the 1-year license to IntelliJ IDEA. And if I read the coupon correctly, I think you can actually get other IDEs. Jakarta EE and the Eclipse Foundation provides hosting on Crowdcast. And we've used them before, but we've decided to go YouTube and Zoom. Then our June 2024 sponsor is Oracle. We can give them a hand for picking up the pizza tonight. So thank you very much. We definitely appreciate that. All right. So our memberships. We're guest members of the Jakarta EE ambassadors. I'm sorry, Jakarta EE working group and the micro profile working group. We're also a member of the Jakarta EE ambassadors and also virtual judge. Now, what are the Jakarta EE ambassadors, right? You're sitting there thinking, that's what are they? Who are they? No, it's not going over tonight, right? So, sorry. Anyway, we're an independent
Jakarta ambassadors.
That's right. Thank you, Mark. So, independent grassroots group of people committed to moving Jakarta EE forward through active community participation and advocacy. And, part of what we do here is that. I'm a committer on 2 of the specifications. Version 1.0 of Jakarta data was just released. Come on. Yeah. That will be part of Jakarta EE 11. Also on the Leadership Council, I'm the vice president. And you can learn more at that URL right there. Thank you. Yeah. I just took over that position a few months ago. So. All right. So what's new? So Java 23 is in ramp down phase 1. And that means, 23. Yeah, 24 is next year. And at the same time, the Java 24 expert group is also formed at the same time. So the next one is always is formed. So these are 6 of the 12 features that will be part of JDK 23 in September. So this means that no other features can be added. And there's a certain policy on how you do bug fixes for all the features and et cetera. And then you can see the other 6 right here. So this is all part of Project Panama, structured concurrency, tied in with virtual threads. Virtual threads was final in JDK 21. So I'm sure this will go final, I'm guessing JDK 24. So we'll figure that out. Also, the Jakarta EE 11 specifications that are finalized, out of the 16 that are getting updates, 13. 14 are finalized. And you can see them right there. That's the first half. I mentioned Jakarta data a minute ago. And then these are the others right here. So these will be part, and there's 2 more, I think, authentication. Yes, authentication and security are getting their reviews and their ballots this week. Okay, so enough of me for the moment. And I also want to mention, too, I want you guys to think about this before we do anything. As you know, I write for InfoQ, and InfoQ has these great conferences that are 3 days, and sometimes there's 2 days of workshops after that. The InfoQ is starting something new this year, and they're calling them Dev Summits. They're a little bit smaller, and hence the price isn't as much either, than the QCons. And there's one in Boston at the end of the month. Now, I was tasked with giving out 2 free tickets. Now you have to, I think that's about $1,000, but you have to, pay for your accommodations and your travel up there. It's up in Boston. So, yeah, think about that. We can give away both of those tonight, or run our random simulation. But think if you want to go. So you have to be. It's the 24th and 25th of this month. So if you can make it, and you don't mind paying the expenses for getting there and your hotel accommodations, it's only 2 days. So just let me know. We'll do that at the end later. And there's also a discount code. So, all right. All right. So I'm happy to introduce Mark Nelson. And he's an architect and developer evangelist. I haven't heard that word in quite some time. It's the advocate these days, right? In the Oracle database team, focusing on microservices and mobile development, messaging, data, and event streaming, in particular with Spring Boot, Spring Data, Spring Cloud, and Oracle. Mark has had more than 30 years experience in IT, has broad and deep experience in areas including microservices, messaging, container platforms, continuous integration, continuous delivery, test automation, quality, configuration management, provisioning, business process management, enterprise application integration, service-oriented architecture, software architecture, performance tuning, and problem resolution. Man, I hope you get a good salary. So he has presented at many conferences as a published author, blogger, and content creator. So without further ado, Mark, thank you for being out here tonight. And we can also thank Doug Dressel for introducing Mark to us. So, all right.
All right. Thank you. Okay, that's for later. So let's see. All right. Give me 1 second. Can you hear me okay through the microphone thing? Is that just for the for the meeting, or is that for, it's not for here as well, is it?
It's all good.
Okay, good. All right, cool. So thanks for coming along. I'm going to talk about making it easy to run Spring Boot microservices in the cloud with Oracle. And I had an intro slide too. So I'm an architect and developer evangelist at Oracle, as you said. I've been at Oracle for about 19 years. And before that, I was at IBM for about 13 years. And before that, I was at university. I'm Australian. You can probably tell from my accent. I live in Livingston, which is just over there. And I have 1 wife, 2 kids, 2 dogs, 3 cats, and 7 chickens, which is almost a Fibonacci sequence, but not quite. I tried to find another sequence that had those, but I couldn't. So it's just a random bunch of numbers. But anyway, and this is me at DevNexus this year with Josh Long, who's one of the main advocates for Spring, who does a lot of YouTube broadcasting and stuff like that. So, all right. So do you know about Spring and Spring Boot in general? Like a little or a lot? Okay, so I'll just go quickly over this. So the Spring framework is 20 years old now. It's designed to make it, easy and productive to develop in Java, which, I don't know if any of you remember, like back in the early days, it was not so easy to develop in Java. When we had to write EJPs and stuff, it was unpleasant to say the least. But so Spring is, aimed at making it easy and letting you have access to modern kind of features and to make it more productive. It can be used for lots of different types of applications. So microservices would be, a key one. But it can also be used for building reactive apps, cloud native, web apps, serverless, even for doing batch processing. So lots of different kinds of applications. And its main, feature is something called inversion of control or dependency injection, which is basically, it allows you to inject various behaviors into your application with a very small amount of code, with normally with annotations. And you'll see some of that later. So you end up writing way less code than you would if you were just using Java by itself. So Spring Boot is part of the whole Spring ecosystem. It's about 10 years old, and it's focused on making it easy to create standalone applications that you can just run. Then you can just say Java jar, away you go, and it'll fire up. So it has a built-in Tomcat or Netty or whatever. Excuse me. So you don't have to create a WAR file and deploy it on an application server and do all that kind of stuff. So it's well suited for microservices where you want to have one application running in a container probably, and have all of its dependencies included and all that kind of stuff. So it's really well suited to the microservices use case. They have a lot of starters to make it easy to manage dependencies and the build system. So the starters are basically things that you can add to your project. So for example, if you want to use a database, you can add the Spring Data JPA starter, for example, which will give you access to JPA, and you can create repositories and entities and access them and all that kind of stuff. And there's lots and lots of these starters for all kinds of different behaviors that you might want to have in your system. And the other interesting thing about the starters is they usually include auto configuration as well as the dependencies. So they manage bringing in the dependencies that you need at the right versions and all that kind of stuff. But the auto configuration is really interesting too. So in Spring Boot, they try to have sensible defaults for everything. So the behavior that you expect is usually what you will get. Like you normally don't have to go and configure things a lot. So if we go the example, you want to put things in a database, you obviously have to tell it that the URL and the username and password, but everything else it'll know how to do the right way for 90% of the applications. You don't have to worry about it. Of course, you can always go in and tweak it if you have some special requirements, but a lot of things will just sort of work automatically out of the box. So here's an example of a Spring Boot application. I don't know why it's dark over here. It wasn't dark like that when I made it, but anyway, you can see here it's got this annotation REST controller that's telling it to make this class a REST controller, like expose this over the web server as a REST controller on this URL. Here's a method. It's got a get mapping annotation on it. So this is saying this is going to be a get method, a get REST method on this URL, API v1 customer. That takes a parameter called ID, and we have another annotation over here to grab that parameter and bring it into the method, and so on. See, this returns a response entity of customers, which the response entity lets you get at all the things like the return code and the headers and all that kind of stuff that you might want to set. So this is doing a lookup in a database. This customer repository thing is a JPA repository, getting the customer using the ID, and then it's basically checking if it got a customer, it's going to return it with a HTTP 200 OK, wherever that is over here. If it didn't, it's going to say not found, and if something bad happened, it's going to give you a 500. Okay, so you can see it's not a lot of code to get access things in the database, do searches, handle the HTTP session and the request and the response and all that kind of stuff. It's a relatively small amount of code, and a lot of the behavior is coming from those things that are injected using those annotations. So this is a couple of interesting charts. This is from Stack Overflow. That one's from GitHub, and I have lots of these from other sources too, like the JRebel review and the state of Java and all those kinds of things. But the interesting thing is all of these charts tend to come out the same. You notice that Spring and Spring Boot together here account for like 90% maybe, and in that one, this is actually cut off. The Spring bar here is actually 890, so it goes right up to the top of the screen. So Spring is by far and away the most popular framework that people are using to build microservices in Java. according to many different sources. And we did a lot of sources. We looked at things like job ads, training, certification, as well as repos and search trends and all that kind of stuff. And a lot of other people have done similar research and come with similar results. So, everybody's using Spring Boot, basically. And that's why we, as Oracle, are investing in making it easier to use Spring Boot with Oracle, because, so many people are using it, we'll make it easy. Okay, so what have we done? So I'm going to go through like a whole bunch of stuff, and I'm not going to go into super deep detail about things. I'm just going to give you like a view of lots of different things. If there are things that people are interested in, we can talk more about them, like later tonight, for example, or whatever, or you can, email me and we can chat. But I'm just going to give you a flavor for a bunch of different stuff. So to start with, Spring Boot Start, as I mentioned before, these are the things that let you bring in the dependencies and do the auto configuration and all that kind of stuff. So we have a number of Spring Boot starters. Do any of you use Oracle, by the way? Database, Oracle database? Yeah, a couple, okay. That's all right. Use MySQL? All right. Okay. So we have starters for the database. We have one for something called universal connection pooling, which I'll talk about later. It gives you access to all the high availability features like clustering and sharding, that kind of stuff. We have a starter for wallet-based authentication, which lets you use mutual TLS to authenticate to the database and encrypt all the traffic and that sort of stuff. One for JMS. We also have starters for a bunch of our cloud services. So things like the storage service, like object storage and so on, streaming, queuing, notifications, logging, functions, and so on. And we have also starters for coherence, which is our in-memory data grid product. And we're adding to these all the time. So, we're constantly keeping them up to date and adding more and more starters. So, the point being, if you're building a Spring Boot application and say you want to have access to like streaming in Oracle Cloud, you can just bring in the Oracle streaming starter and it'll auto configure everything and away you go. JDBC sharding is another area. Sorry, I've got the allergies too from the trees. So we contributed sharding support to Spring JDBC 6.1.2, which was, I think, about a year ago. I think we're up to 6.1.4 or something now. I'm not actually sure, something like that anyway. So sharding lets you basically, sharding is where you have a database and you have lots of databases, like instances all running, and they pretend to be one big database, and they use some kind of key to spread the data across them. Like, if the surname starts with an A, it goes to that one. Starts with a B, it goes to that one, and so on. So sharding, provides linear scalability and fault isolation, and it's also very commonly used for where the sharding key is a country, where you want to keep data for different countries in databases that physically reside in those countries. Okay. So we added this support. This works for any kind of database that can be accessed through Spring JDBC. You basically implement a sharding key adapter where you tell it, what the key is, and then based on that, whenever you use a JDBC template, for example, to run a query, it will automatically connect to the shard that has the data, or would have the data in it that based on your sharding key. Okay. So that is supported with JDBC and JPA, which are two different ways of accessing databases in Spring. Spring JPA is much more popular. Probably 80–90% of people use that. And it uses, you basically create POJOs that represent your entities, and it does mapping and automatically generates SQL for you and all that kind of stuff. And Spring JDBC is more low level, where you write the SQL yourself that you wanted to execute. Okay. Reactive streams ingestion. I'm just going to go through a bunch of different areas. It'll all come together at the end. So reactive streams ingestion is an interesting thing that we have done. So this is a reactive Java API that lets you do non-blocking ingestion of huge amounts of data in a very small amount of time, and potentially from multiple clients feeding into a database. So this works with Rack. Rack is like a cluster of Oracle databases, as well as sharding, and it basically spreads the workload across all of the machines that are running the database. Optimizes CPU allocation and thread scheduling and so on. For those of you who know Oracle, you may, I don't know, some of these words may be nonsense, but just go along with me. So there's something called a direct path insert. So normally when you insert into Oracle, like you say, insert customer, insert into customer, blah 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 blah, it actually writes it into a cache, and then later it writes it into the disk, right? And then when you do a commit, it makes sure it's got it copied on the on the disk before it lets you go to commit the transaction. This actually bypasses that and writes straight to the disk, so you don't have that delay of going through the cache, which means we can do it much faster. So here's an example. So this is creating the reactive streams ingestion object here, connecting to a database, username, password, schema, all that kind of stuff. You can set up the size of buffers if you want to use them, which entity you're going to be writing into the database, and you put it into a thread pool. And then you basically go ahead and grab the publisher and start shoving objects into it. Okay. And so you can run multiple threads. There can be multiple copies running and so on. And it'll basically let you get data into the database much faster than you could otherwise do. So this kind of thing we see used a lot for things where the data is changing very rapidly, like share prices or stuff like that, or trains moving around a network, or trucks sending in GPS coordinates and speed and things. We have a large volume of data coming very quickly. This is where that technology is commonly used. Okay, another thing we put into JDBC is support for OpenTelemetry. Does anybody know about OpenTelemetry? Couple? Okay. So this lets you basically trace the execution of your code to see what's going on. So in a microservices environment, you could imagine maybe you have a client coming in through like an API gateway, hitting some microservice. That microservice might send a call to another microservice. That one might do something in the database. It might call another microservice. Maybe it puts a message on a queue or a topic or something, and a whole bunch of stuff is happening. So OpenTelemetry lets you trace the execution path through all of those different programs and out into the databases and things, so that you can see what actually happened, how much time was spent in each of the parts, and that sort of thing. So we've added OpenTelemetry support in JDBC, which will give you the ability to see when you go to a database, it'll show you what actually happened. So here it's saying it executed a query. You can get the SQL ID from the database and the thread and all that kind of stuff. So you can see what was happening. So this is currently available. The way you use it is by adding that starter and setting this property in your Spring application.properties or YAML file. We are currently working on going deeper down into the database. So in addition to getting something like that, you would see how did it execute the query? Like, did it do a table scan? Did it use an index? Did it do a join? What kind of join? How long did it take? And like much more detailed information that you could use to optimize, the queries that it's running. A lot of these slides have links on the bottom of it. I assume I'll give you this and you distribute it to everyone, right? Yep. So the links are, if you want to get more information about any of these, you can go drill in. Okay, so back to UCP again. So UCP is Universal Connection Pools. So this is when you connect to a database from a microservice, you typically would use a connection pool rather than just making a connection. So you can have a number of connections and they're shared, in a pool scenario. So the default connection pool in Spring Boot is called Hikari, which is good, and it understands all kinds of different databases, but it's kind of like a lowest common denominator, right? So it understands how to connect Oracle and Mongo and Cassandra and MySQL and everybody else, but it doesn't really understand any of the special unique features of any one of those databases. And you know, a lot of the time that's just fine. Like a lot of applications don't need any of those special features, but sometimes you do. So using UCP gives you access to a bunch of Oracle high availability features like RAC, which is a cluster of databases rather than a single instance. Sharding we talked about. Things like data guard, which lets you automatically copy data between multiple, like an active and a passive database for a failover. Database resident connection pooling, which lets you do the connection pooling on the database server instead of on the clients, which is useful. Like imagine if you have, you know, 20 microservices, and for each one of them, you're running maybe 5 or 10 instances of them. That's like maybe 200 already. And each one of them is opening a connection pool with 10 or 15 connections. That's like 2,000, 3,000 connections already. Like that's a lot. And most of them are going to be wasted and consuming resources. So if you let those 200 service instances do the connection pooling in the database server, it can be much more efficient because it can share them across all the different instances and applications. And so on. So there's a bunch of other, you know, fast application notifications and transparent application continuity, which lets you, you know, basically if one of the database servers goes down, another one will take over and your application won't even know that it got swapped. So, you know, there's a bunch of high availability features available in here, which you can get access by swapping from Hikari to UCP. So we are currently working with the Spring team at Broadcom. For those who don't know, Broadcom just bought VMware, and VM like bought Pivotal before, so Spring came from there. So Spring belongs to Broadcom now. So we're working with some folks at Broadcom to create open rewrite recipes to automatically migrate applications from Hikari to UCP for when you want to do that. Has anybody used open rewrite before?
Yeah.
Okay, you should check it out. It's really cool. It basically lets you do code refactoring, like automate code refactoring. So they have recipes for all kinds of stuff. So for example, there's a recipe to upgrade from Spring Boot 2.7 to Spring Boot 3.0 or 3.1 or so on. So you basically, you just add a dependency to your POM and you say, you know, Maven rewrite or Gradle rewrite or whatever. And it'll go through and it'll update all the dependencies and make sure everything's correct for the new version. Make sure your Spring Cloud matches your Spring Boot. It'll do things like change things in your code to use new language features that were introduced in later versions of Java, and that sort of stuff. And you can write your own recipe, so you can do like whatever you like. So you can use it to like automate, you know, common refactoring or stuff like that. So, you know, if you have a lot of applications that you need to upgrade, you know, maybe you could spend, you know, a bit of time creating the recipes and then just automate the whole thing rather than manually going and updating them all. So it's pretty cool. If you haven't used it before, check it out. Open rewrite. Yeah. It's from, I can't remember who wrote it. Yeah, Moderna. Okay. Yeah.
Jonathan Schneider actually was here last year.
Yeah. Yeah. Cool. It's cool. It's very good.
Yeah.
You still haven't tried it yet?
No.
Not really. It's like one or the other. Yeah, one or the other. I mean, Hikari can actually understand a little bit of RAC and DRCP, I think, if you configure it the right way. But a lot of the other features it doesn't. They just, because it's like a common denominator across lots of different databases. So they don't have any database specific features in it really by design. Yeah. Yes. UCP is a client side thing. Yeah. So it basically it basically replaces Hikari. So you take Hikari off the class path, you put UCP on the class path, and then when you go create a data source, like a data source, you know, bean or whatever, it'll just use UCP instead. Yeah.
Okay. Thank you.
Yeah. No problem. His question, just for the recording or whatever the question was, is UCP client-side or server-side? Yeah.
If you have a question, yell to me and I'll attend you.
This, yeah. DRCP is server-side. That's database resident connection pooling. That's on the server side. But UCP is the client. Okay. All right. JMS. Does anybody use messages? Messages? All right. So some of the microservices, architecture people say that everything should be asynchronous and you should use messages because it scales much better and all that, which is almost certainly true. But a lot of people still use REST and gRPC and all that kind of stuff. But anyway, asynchronous communication between microservices is an important thing, and you can do that with JMS. In the database, we have a feature called transactional event queues. If you've heard of advanced queues, it's basically the same thing. It's a rewrite of that to run in memory, so it's low latency, high performance, etc. So it scales to like millions of messages per second. And also supports the Kafka, Java, and REST APIs, as well as JMS, but we're talking about JMS here. So we have written a JMS binder that will allow you to use the queuing in the database in your applications, and it just plugs in again. You just add the starter, you put that on your class path, and then anytime you use the standard Spring annotations like a JMS template, if you want to send a message, or a JMS listener, if you want to receive messages, it'll automatically just use those queues for you. So very good. So this is a coming soon. This is written, but we're waiting for the lawyers to give us the permission to publish it, as you do. All right. Let's talk about sagas. Is anybody familiar with sagas? All right, cool. So yeah. So sagas, when you have when you build a lot of microservices, there's a very common pattern called the database per service pattern, which basically says that the data that belongs to the microservice should be in its own data store, which is a private implementation detail, and nobody else should be going in there and messing with that, like reading those tables, doing joins, or anything like that. The only way you should be accessing its data is through its public API, like its REST API, or by sending it a message or whatever. So, not everybody subscribes to that pattern. Some people do, some more religiously than others. But if you do, you always get into the situation where you've got multiple databases and you need to maintain data consistency across them. And you have things that take maybe a long time. Like maybe you have to, the classic example they give is like, say you've got to book a flight, and then you got to go book your hotel. But if you can't get the hotel, then you don't want the flight, so you're going to cancel that. And the whole, it's like an all or nothing. But you can't hold a transaction open for your hotel while you're going to, for your flight, while you're going to find out if the hotel's available, because it'll time out, right? So sagas is one approach to solving that problem, which works by having local transactions in each of the databases or systems, whatever they are, and then registering compensation handlers to run more local transactions to undo previous operations if it needs to, roll back as such. Sorry for coughing all the time. So long-running actions is an implementation of the Saga pattern. It's in the Eclipse MicroProfile project. We have written a Java, a library that's available for either for plain Java or for Spring, take your choice, which allows you to participate in long-running actions using the MicroProfile spec and using idiomatic Spring annotations. So it looks like this. So the spec has a bunch of things. You can create an LRA, then you can join the long-running action. You can register a compensation handler. You can complete, or you can cancel. You can have after LRA. So the number of different steps that you have the ability to use. This is just two. To give you an example, so here's that post mapping again. So this is a REST API on some URL, something/transfer. That's going to take a from account and a to account and an amount. and also this magical header here for the LRA context. And you see this annotation that says LRA, long running action, and it says requires a new one and false. So this is saying when this method is called, it must be in a long running action. If it's not, then it will refuse to be executed. The requires new says create one. So it'll go talk to the coordinator and say, give me a new long running action, ID. If it can't get one, it'll fail. And end false means that this shouldn't close the long running action when it's finished. It leaves it open because more things are going to happen. And, it does something. I left out what it does, but so here's another example. See, this one is mapped to some URL, something /confirm that has the complete annotation on here. And here's our LRA again. So this is saying when this is called, it is going to, when the LRA goes into its completion phase, this method will get called by the transaction coordinator, the transaction manager, to finish whatever work this participant needed to do as part of the long-running action. Okay, and there's another one obviously for cancel and so on. So again, you see it's similar. Like the annotations are very similar to what you use all the time in Spring. You're not running a whole bunch of code. You're sort of injecting the behaviors. So it's a very idiomatic implementation. We have one of those transaction manager things. It's called MicroTX, or its proper name is Oracle Transaction Manager for Microservices, I think, but we call it MicroTX, which is a lightweight containerized transaction manager. It's actually written by the exact same people who wrote Tuxedo, which you may have heard of, which is a venerable, old, very successful transaction manager. Doug worked on it back in the 1800s when he was a young boy. Yeah, from BEA. Yep. So same people wrote this one. This is much more lightweight, so it'll run in a container, and it supports the three most common patterns that people use today, being XA, extended architecture, which is the classical two-phase commit, long-running actions as an implementation of the Saga pattern, and try, confirm, cancel, which is another pattern it's much more common in a lot of Asian countries compared to here. People here tend to use LRAs for some reason. People there tend to use try, confirm, cancel. Sorry. So MicroTX, there's a free version, supports multiple languages. It does have a high availability configuration option, can run multiple instances. It can participate in the service mesh, and it's observable in all the normal ways. All right.
Yeah, question on the long-running actions.
Yeah.
Like the Spring Boot one.
Yeah.
Is that scoped to just a specific Spring Boot microservice, or can it cross multiple?
So a Spring Boot service would be a participant in a long-running action. So that the action would, almost by definition have multiple participants. Might be multiple services. They don't all have to be Spring Boot. They might be something else. Yeah. And one of them is responsible for starting, the long-running action, and the others will do their pieces, and then somebody will decide we're finished, and either we're going to confirm, and everybody will go confirm, or we're going to cancel, and then everybody will go compensate.
Cool. Thanks.
All right. I didn't pay him to ask questions. All right. So let's talk about native images. So is anybody familiar with Graal VM? Okay, a few. Good. So if you're not, Graal VM is an alternate JVM that we have built in our Oracle Labs research division. It's written in Java, which is interesting. And it's a little bit faster than the JVM, which is also interesting, given that it's written in Java and the JVM is written in C. And it does a bunch of interesting things. It's a multi-language polyglot VM that can run not just Java, but JavaScript and Python and R and a bunch of other stuff as well. It actually uses a very small low-level VM that's called Substrate. And one of the interesting features it has is something called native image support, or ahead of time compilation. So you can take a Java program, you can run it through the Graal native image compilation, and it will create for you, essentially a binary, like a native binary that you can run on a machine. Strictly speaking, it's actually going to run on Substrate VM, not like on the bare metal. Sorry, I keep moving around out of the camera. But nonetheless, for all intents and purposes, it's as much of a native image as something that's like linked to glibc or something is a native image, right? So think of it as like a native executable. And the reason that you might want to do this is they tend to be much smaller, but they don't use as much space to store them. They tend to start much faster. They tend to have less memory usage. And they tend to have less vulnerabilities because you're eliminating all of the stuff that's not needed. So for example, when you build an Uber jar from your application, it's going to go packaging everything, right? From all the jar files, all the methods and everything, and all the classes are there, and they're in their class file format. This only takes the things that are actually in the call path. So if you import some library, but you only ever call one method out of it, only that method will end up in the executable, nothing else from that library. So you're eliminating, unused code and attack vectors that could be present in a pure Java, in a jar file. So to give you an idea of the kind of performance improvements, so Spring has a sample called Pet Clinic, which is based on the old Java. Was that called Pet Clinic too? Oh, what was it called? Pet Shop. Pet Shop. Yeah. So this is comparing a application running on a JVM. It's actually the Graal JVM, but using just-in-time compilation. So this is a normal Java application running on a JVM with class files and in a jar file compared to a native image. So this is like this binary image format. So if you look at the memory usage, and this is for Pet Clinic. So in JVM, it uses like a gigabyte. On native image, it only uses 640. So that's 38% less, which may not seem like much, but if you're running thousands of these in a big, cluster or in the cloud, or you're paying by the amount of memory you use, that could add up very quickly to a lot of money, right? Throughput, it's a little bit faster, nothing super fancy there. Throughput compared to the amount of memory, though, is probably interesting. It's about 50% faster based on the amount of resource that it's consuming. Latency is lower, which is good. So it's faster. The response time is faster, and the startup time is a big one. So this is like where people really get interested in using native images, especially if you're doing serverless or scale to zero. So these things, this is a bit slow for a Spring Boot application. Normally it's 3 or 4 seconds. This one starts up in 7 seconds on a JVM, but the native image starts up in 200 milliseconds, which is 34 times faster. And it's common to see hundreds or even thousands of times performance improvement in the startup with these applications, depending on what they do in their startup, obviously. But you can see them be, orders of magnitude faster in startup. So if you're running, in say in a serverless in a cloud, and you want to be able to scale very quickly when a bunch of workload comes in, this is perfect for that kind of use case. They'll start very fast. They use less memory, all that sort of stuff. So it's cheaper and faster and all kinds of good things. And they use a little bunny rabbit as their logo now, because bunnies are fast. Not the bunny that lives in my backyard. He's a bit slow. But my dog isn't caught him yet.
So Mark, I just noticed on the Helidon blog that migrating a Spring Boot project to Helidon.
Yes.
And since Oracle, of course, developed Helidon, is it
absolutely
is kind of related to that? Or
Helidon is another fine framework for building applications, and it's one that Oracle write. And we also do Micronaut as well. So there's lots of choices. It's horses for courses. I'm talking about Spring Boot today because like that chart I showed you at the beginning, you may have noticed that there was not a Hilidon column on there because it didn't make it. The number was not big enough to score. So, our team are working where, we know lots of developers are using this particular framework. So that's what we're working on.
Cool. Thank you.
Hilidon is great too, but
Oh, yeah, I've been studying that.
Yeah.
So, yeah.
And Micronaut is like a Spring Boot compatible thing.
Yes.
It's kind of a hybrid.
Sort of Micronaut app, the same.
Yeah.
as Spring Boot, right?
Yeah. Okay, test containers. Anybody use test containers? Cool. That's great. You should try it. If you haven't tried it, go home tonight and try it.
Don't knock it until you've tried. Certainly.
All right. So test containers is it's a thing that lets you basically fire up your stuff that you need to run, say, your integration tests in a bunch of containers. Okay, and it's integrated into Spring really well. I'll show you in a minute. So you can use your idiomatic Spring annotations to describe what you need. And if you want to write an integration test in Spring, for example, and you need a database and a Kubernetes server and a Kafka and whatever, you can just have it fire all of those up when you just say, like, Maven verify or whatever. You don't have to go worry about, I need a Docker Compose file and is it up and running or not, and all that kind of stuff. It's all in your code, which is great. So Oracle database, the 23 AI, that's our new release of the database that we released free for developers about a year ago. And the production release came out, I think, 2 weeks ago, something like that. It's available as a container image. And there is a fast start version of that will give you a full Oracle database with all of the features that's in the full Enterprise Edition. And it'll boot up in about 10 seconds, which is pretty respectable. It's not MySQL, okay, or H2, but at 10 seconds, if you're running an integration test, 10 seconds is not a lot of time. And, a lot of people we know will write their applications and test them against MySQL or Postgres or something that starts quickly because it's quick and easy, right? And it's a pain for them to get an Oracle database and all that. But then they deploy it into production with Oracle. So you're testing against, not the same thing that you're going to be using in production, which is not ideal. So, I'm really excited about this test containers and the Oracle database support in there because, you can test your applications against the same thing that you're going to run them against in production, which is great.
Container registry.
It's in Docker Hub.
Okay,
Yeah, take a picture of that.
super.
I can tell you later. So this is an example of an integration test. Like he said, I love testing and stuff. You said testing and quality in the intro. That's true. I love tests. Doug remembers I used to give people a hard time for not writing tests. So here's a test. This is the start of a test. So here we go. This is actually placeholder integration test. This is a test that I wrote to show other people how to write tests. So here we're saying at test containers. So that tells Spring, bring in the test containers support for this test. I've got here a Spring Boot test, which tells it this is a test. I want to run this full Spring application context, like the whole thing. There's also, by the way, does anybody use slice testing like web MVC test or data JPA test? If you haven't, you should check them out. They're cool too. Like, for example, in the web MVC test, you can just start the MVC layer without all the other stuff, like no databases or JPA or anything like that. So it just starts up like a slice of the application, and then you can mock out the stuff you don't care about, like the database access and all that, or other services that you might call through, Feign or whatever it might be, and just test the piece that you're interested in. So that's really cool. But anyway, this is a full Spring Boot test. See here, it says web environment, random port. So it'll fire up Spring, it'll make up a port, find a free port, and you can grab it here by using a value annotation so that you can use that port later on. And then we say here, I want an Oracle container. So you say, give me an Oracle container from this Docker image. So this is the fast start version. If you don't specify an image, it'll use like the regular one, which might take a minute to start up. This one's a lot faster. This is the one I use all the time. And you can say, you know, create this user and password and all that sort of stuff. And then we can use a dynamic property source annotation to grab the URL and the username and password and everything from the container that got created. Okay, obviously we don't need to grab the username and password because we know what they are, but we do need to grab the URL because we don't know what IP address or port or anything that container is going to get allocated. So that's how easy it is to grab a database for your test. So when you run this test, when you say Maven test, it will actually fire up Oracle in a container, give the test access to it through the properties here, and then you can go do whatever you like. You can create a data source, you can create a JPA repository, you can write records, do finds, whatever, and it'll throw away the database when the test finishes for you. Okay, so that's pretty cool. You can also control things like you can say that one of your tests dirties the context, which will force it to rebuild the database each time, so you know it's always a clean, empty one. You can pre-populate the database with tables and stuff like that if you want to. So there's lots of interesting stuff you can do. I didn't put a link to, I have a blog post on LinkedIn about this, but I'll add the link before I give you the slides. So test containers, really cool. Great for integration testing. All right. Moving right along. Data refactoring advisor. There's a lot of stuff, right? So another problem that we commonly have, you know, people have monolithic applications, they have a monolithic database. All of the database tables are in the same schema. They've written queries, everybody's fiddling with everybody's stuff, nobody knows what's going on. It's a big total mess. So how do you work out how to move some of that out into a microservice? So I mentioned the database per service pattern. Microservices, people like to have what they call a bounded context, meaning it's got its own, you know, data that it owns, or you may hear it called a domain or a data domain, or there's other names for it. But basically, there's a set of tables that belongs to that one microservice. So we have a tool that we've been building and testing with different people that helps you to figure this out. Doug is actually working on this tool right now. So what it does is we record how you use your database for some period of time, like a day or a week or whatever makes sense, you know. So then we run it through a little workflow. So we capture the actual usage of the database. Then we calculate the affinities between each pair of tables in a big matrix. And then we, you know, project the matrix into a graph, and we run the InfoMap community detection algorithm over the graph, which finds the communities or the clusters that belong together and gives you an output that looks like this. And then you can, you know, tweak the knobs. Like you can say, well, you know, that maybe that one and that one really should be in the same cluster. So let's change that to 1, run it again, and so on. And then, you know, it could pump out at the end, say, here's how you're going to create the schema for the ones that you identified. Do I have another slide on this? No. Go back. So this is a really interesting tool. We have run this on some very large databases with tens of thousands of tables, and you know it's interesting to see what it does. And it's interesting because it's not just looking at the tables and things like the constraints that you define, like foreign keys and that sort of thing. It's looking at the actual queries that your application runs and what they do, like whether they do joins, what kind of joins they do, whether they do a full select, all that kind of stuff. So it's analyzing not the structure of your database, but how it's actually being used. Okay. Who would like to version control their database, like they version control their code? Yeah, why not? Why not? Okay, so there's a thing called Liquibase, which is a separate company. They have a technology that lets you do this, right? We have, for the people who used Oracle, if you probably used SQL Plus, right? To like type in SQL, and it's awful. I always hated it. There's a new thing we have called SQL command line, which is way better. It's just like SQL Plus, but like it has tab completion and up arrows and down arrows. Like you can go back to a previous statement and edit it, and you can say select star from Bob or something, and you can go back to the star and hit tab, and it will give you a list of the fields that are in Bob. Mind-blowing stuff. So anyhow, liquid base is included inside of SQLCL, which is great. So you can do things like version control your database schema, so the definition of your tables and indexes and views and all that kind of stuff. And you can put that in your code. So when you do a branch and you start working on a new feature, and maybe you add another table or you add a column or whatever, that's all version controlled together in the same branch with the code that uses it, which is a great idea, right? So when you run the test and it starts up the application, it's going to go and adjust your database to match what it should be for that branch, and put it back later when you're finished, which is great. It's also integrated into Spring. So this is what a liquid base file looks like. So this one is in Oracle SQL. So you can use native SQL. Liquid base works with lots of different databases. Okay, so if you're only using one, you can write SQL for that database. If you're using lots, you can model all the same information in YAML or JSON or XML format. I don't know if anybody still uses XML, so let's say YAML or JSON. So you define all the objects and stuff, and it generates the correct SQL for the database that you're using. But it looks similar. So you can see things here like, see this as a change set. It has some preconditions. It checks if things are happening. It tells it what to do. So here it's going to create a table and a constraint on it. And then it tells it what to do if there's a problem, how to do a rollback. Okay. So I think I have another slide. Yes. So it's, like I said, it's integrated into Spring Boot. So if you add liquid base starter into your Spring Boot application, put it on the class path, then it will go look for those liquid base definition files very, very early in the startup, before it starts any of the repositories or the REST controllers or anything like that. It'll connect to the database and go do the stuff. So you can either say, go create all this stuff for me, create these tables, create this reference data, do a bunch of inserts, whatever it might be. Or you can have it check the database to see if it matches, and then figure out what it needs to do to bring it into line. So like maybe it'll figure out, I need to add one more column to this table to make it match what you've defined, and it will do that for you. And so on. And you can obviously also have it take control at shutdown time and go and clean up stuff. So again, it's a great thing. It's great in tests as well. So, if you combine this with the test container stuff, you can say, fire up my database, go create all this schema for me, these tables, all that kind of stuff, and then run my tests. You can load up all your sample data, your test data, and it's all version controlled, and if you change something, you can do it in a branch. It's a beautiful thing. So if you haven't tried this, liquid base, there are others too. There are other alternatives that do the same thing. Flyway, I think, is another one. But this one is integrated into Oracle and into Spring, so it's worth checking out. All right. Let me take a 5-second break and get myself a glass of Coke. All right. Oh, thanks. Does anybody know who that guy is? I know Doug does.
Is that Oliver?
Yeah. It's Oliver.
Please, can I have some more?
Thanks. Yeah, he said, please, sir, may I have some more? All right. So there's more. Okay. So far I've been talking about little bits and pieces all over the place, right? And we built so many of these bits and pieces, we thought, well, why don't we put them all together and build like a out-of-the-box stack thing, like a bundle. And so we did. So we created something that we call Oracle Backend for Spring Boot. And what we did here is there's a very common pattern in mobile application development called mobile backend as a service, or backend as a service, which, anybody heard of that pattern? I know Doug has. backend as a service. The idea is, mobile app developers don't care about the backend. They don't care about, I need a server, my database has got to be on a server. What's a server? I don't know. How much memory? Who cares? Like, just give me an API, and I'll say, like, give me a place to shove my data, and like when I ask for it back, make sure it's there. Right? I don't care what you do with it. I want to send a message to my users. I want to do a transaction, like take some money from them, or what else do mobile apps do? I want to get the location of the device, or give me all the devices in this location and send them a message, stuff like that. And it's all just an API, right? You just call an API. You don't have to know how it's implemented, how it's configured. You don't have to keep it up to date, any of that kind of stuff. Somebody else's problem, right? On the cloud somewhere, who cares? It just works and does what you need. It scales up, scales down. You only pay for what you need. So that's a very, very common pattern, backend as a service. And what we try to do is apply that very same pattern to Spring Boot applications. Okay, so we created this thing, Oracle Backend for Spring Boot, which basically it provides all of the common stuff. I put everything on there, but most of the stuff that you would need when you're running a Spring Boot application. Okay, so typically people will, you need somewhere to run it, like maybe Kubernetes cluster, right? You probably want to have a way to do service discovery. So you might want Eureka or Console or something. Sorry, excuse me. You might want to use Spring Config to inject configuration into your application, so you don't have to burn into your container images things like your credentials or your URLs for databases or whatever. You have that injected at runtime, right? Much more secure. You might want an API gateway so that you can give access to clients and control things like rate limiting and throttling and authentication and so on and so forth. So we took all of these bits and pieces, put them all together, and integrated them to make sure everything works together, everything's configured the right way, and so on. And this is provided as like a Terraform stack that you can just go, Terraform apply, and it'll just fire up a backend for you. You can run it on Oracle Cloud, or on Azure, or on premises, or your preferred cloud provider. We actually announced, I believe, this afternoon that we have entered into some kind of agreement with Google to provide database services, Oracle database on Google Cloud as well, same as we do on Azure. So it would be a reasonable guess to think that GCP would appear on this list as a first-class citizen in the not-too-distant future as well. It's free to use. Obviously, if you go run it on Azure, you've got to pay them for the compute and whatever, but the product itself is free. And we provide support for customers who have an Oracle license. Okay, so here's some of the stuff that's included. I'm not going to go through it in all the details, but it has things like platform services I mentioned, service discovery, external configuration, workflow, that's Netflix Conductor, transaction management, that's the MicroTX thing that we talked about before. It has a full observability stack based on Grafana and Loki with Promtail, and Jaeger and OpenTelemetry for tracing. Resiliency with Resilience for J, fault tolerance, API gateway is API 6. It has an Oracle database, you'll be surprised to hear, so that you can put your data somewhere and use queues and JMS and all that sort of stuff. They're all configured for auto scaling, so it'll scale up and down based on usage. And it has a bunch of nice developer-friendly APIs and SDKs. Has a Vault, it's HashiCorp, and some other bits and pieces. Okay. It also includes a full mobile platform. So has anybody heard of PaaS? Right. What's the other one called? Firebase. You've heard of Firebase? Okay. PaaS is like Firebase. So PaaS, I don't know if you remember at the beginning of Facebook, before they became really evil, they decided they were going to have apps. Right? No, they're not evil. They're not evil. You're not evil. No. They had this thing where they were going to have apps on their platform, and they bought PaaS, and that was the platform that they used for people to write apps on Facebook. And after a while, they decided, you know what, we don't want to do apps. We want to just do the whole social network and blah, blah, blah. So they open source this, this platform. So if you haven't, this is another thing, I know I've said this a few times. If you've never tried Pars, you should try it. It is so refreshingly easy. It's like unbelievable. You go write an application with this thing, and everything's just so simple. It's kind of mind blowing. There's not like you don't have to go through a 7,000 page setup document before you can do something. That's really nice. So it provides a whole bunch of features like you can store documents, because mobile apps typically use documents like JSON documents, rather than caring about rows and columns and stuff. Sending notifications, doing microtransactions, collecting, your dumps and traces and stuff when your application crashes on the device, having local storage on the device that works offline. So if you go into a tunnel or something, you can still do things, and then synchronizing the database back to the mothership when you get back onto the network. What else, Doug? Stuff, all that kind of stuff, all that geolocation. Yeah, push config down to the device, push notifications, all that kind of stuff, that you would want to build a mobile app. And we have SDKs for the full iOS and Android ecosystems, meaning phones, tablets, TVs, and cars. Also for JavaScript, and in particular React and React Native, for Flutter, and there's also stuff for like C and Python and others that are somewhat less common in mobile app development. So you can use this for building web apps as well. It doesn't have to be mobile only. So this is really cool. Doug did a lot of the work to make this work with Oracle. And this is also included in there. Okay. We also have a thing that we call the Spring Operations Center, which is a GUI that you can use to manage, your operations stuff. So it lets you see, where's your things, where you're running, how many applications are deployed, what versions are you on, that sort of stuff. I just have a couple of screenshots of this. You can, this is an example of deploying an application. So you're going to give it the jar file. It'll go and automatically build a container image from it, applying all of the best practices for security, using the right base images, minimizing the utilities that are available in the image, creating layers to optimize storage and load time, and all that kind of stuff. So, yep, like a nice UI. We also have a command line version of this, and we have a VS Code plugin, and we're building an IntelliJ plugin as well. We did the VS Code one first because all the Spring stuff is free in VS Code, but in IntelliJ, the Spring stuff, you have to have the Ultimate Edition that you pay money for. It's not included in the community one. So whoever wins that license today will be good to go. Okay. A few screenshots of some of the other bits and pieces included. This is what we use the Eureka service registry for service discovery. You can also use Kubernetes service discovery if you choose. So for example, if you want to use Feign to make a call to another microservice, it will hook up to the registry. You provide the key like credit score, and the registry will come back with the addresses of the currently running and healthy instances of that service so that you can make a call to it. We have the API 6 API gateway, which you can use to expose services to the outside world. There's a full Grafana and Loki stack. There's a bunch of dashboards. This is an example of one of them, which is called Spring Boot Statistics. This is looking at one instance of one service, I think. And you can see it's showing you stuff like the heap usage and threads and garbage collection and all of the normal JVM statistics and stuff it gives you access to, as well as HTTP, connection pools, and all of that kind of stuff. Example of a trace. We talked about traces before. You can see here something particularly bad is going on here in this notification service. It's taking a very long time to run that query. So there's a problem there. All right. So then after we'd done all of that, we thought, how's anybody going to use this thing? So we built a sample application that we call Cloud Bank. If you want to check it out, you can scan that thing and it will take you to it. I hope. I hope I put the right one in there. So it's like, you know, a bank thing. It's got a bunch of microservices. There's one for customer, one for accounts. There's one that does a transfer, a credit score. There's check processing. And they're all implemented a little bit differently to showcase different things. So the customer one and the account one use REST and JPA to store stuff in the database. The check one uses JMS messaging, so everything is asynchronous. It doesn't have any synchronous API. The transfer one is a Eclipse micro-profile long-running action that runs transfers between multiple accounts. So it does does a debit somewhere or whatever that's called, the deposit, withdrawal, deposit, make sure everybody's happy, commits everybody, and that sort of thing. And it has rollback. And you can run through if you transfer to an account that doesn't exist, or if you transfer more money that exists in the from account, you'll get different failure scenarios, and you'll see it'll roll back and all that kind of stuff. So this implements a lot of the different kinds of things that we've been talking about and shows you how to use them. A lot of them use Liquibase to set up their schema and everything at startup time. They're all plugged into the observability stuff. You get the distributed tracing across all of them. So it sort of demonstrates all of the pieces working together. And we also have a mobile application written in Flutter, which is interesting framework because it allows you to create applications for different platforms from the same code base. So unlike React and React Native, does anybody use that? React Native? No front-end people here? Just you.
Flutter.
You use Flutter. So React is for web apps, and React Native is for on-device apps, right? Like phones and stuff. And they're very, very similar, but they're not the same. Like the layout is different. You use different components, right, to do the layout, for example. The way they render is a little bit different. So you can't use the same code. You know, it's very, very similar. The skills are mostly transferable, but it's not the same. So where Flutter is interesting is it's literally the same code, right? You just say, run this as a web app, or run this as a Windows, MFC, whatever they call it now, app, or run this as an iOS app. And from the same code base, it'll run on any of the different platforms. So it's kind of interesting. So we built the app in that because, Doug kind of likes it. He has a Mac. I use Windows. Sorry. I've used lots. I even used OS2 once when I worked at IBM. Yeah, man. Those were the days.
Why would you?
I've done that. I've run Windows on a Mac. I run Linux.
There's literally, I was about to mention, there is literally support on Apple Silicon
Yeah.
URLs.
Yeah.
Have people done that on
I've done
Windows
that.
11?
I've run Linux on my old Macs too to get more life out of them.
I gotta learn how to do that too.
That's cool. So anyway, so this the mobile app, it looks like a banking thing, right? It shows your accounts and whatever, and it talks to the microservices. So when you hook it up, you give it the IP address of your gateway, and it'll talk to these microservices. So it all sort of works together. And then we have a lab, what we call a live lab. Do I have no, I don't have a slide, which shows you how to build this from scratch, from assuming that you've never used Spring Boot before. So it goes through everything, like how do you create a Spring Boot application? How do you create a REST controller and endpoints? And how do you fiddle with the HTTP status and all that kind of stuff? How do you connect to a database? So it goes from first principles all the way through to build the whole thing. The LRA lab is a little bit boring. If you, I'll warn you in advance. Okay. And the last lab, you extend this mobile app to add a new feature, which we call Cloud Cash, which is kind of like Venmo. So you can say, send $50 to, Doug at Oracle.com. And it will go and use a bunch of these services. So it'll go to the customer service and see, do I have a customer whose email address is doug@oracle.com? Yes. Has he got any accounts? Go to the account service. Yep. Find his checking account, then start a long-running action to do a transfer from whoever did the cloud cache thingy through to Doug, and then all that kind of stuff. So it all kind of ties together in the end and shows you how to use all the different bits and pieces. So the live lab thing is a freebie. You can do it on demand, and so on. All right. Sorry, I can't stop coughing. Okay, a few other bits and pieces. We're nearly there. Nobody's left yet. All right. You can run Oracle in Kubernetes. In case you didn't know, we support Oracle running in production in Kubernetes, including rack, which is big news, I guess. We also have a operator, Kubernetes operator for Oracle. So I assume people have heard of Kubernetes. Are you familiar with Kubernetes operators? Okay, so operator is a very common pattern in Kubernetes to handle the special needs of stateful applications. So like in the olden days, in data centers, there were people called operators who would go and pick up the tapes and shove them in the tape drive, when you needed some data, for example. Or if you needed to turn something on or off, they would do that, or they'd move a cable, or they operated the machine. And this pattern is basically the modern day incarnation of that. So things like databases, that need some loving care. You need to create the thing, and you need to give it some storage. Maybe you need to do backups. Maybe you need to patch it every now and then. Put on this maintenance for security fixes, whatever. All of those kind of life cycle things. Rather than a person doing that, like a DBA, you would have the operator do it. So you'd say, the operator is just a program that knows how to do those things. You'd say, hey, operator, give me a new database called, Fred or whatever, and I want it to be this big, and I want backups every day and whatever, and they'll go do that for you. So the operator can manage the databases that are running inside Kubernetes itself, inside a container. It can also connect to cloud providers like Oracle and Azure and soon to be Google, and create databases there, like managed service databases outside of Kubernetes. And it can, even if you have like an Exadata machine or something in your on-prem data center, it can connect to that and create databases and things there for you. And it manages all the kind of lifecycle operations like these: provision, cloning, patching, updating configuration parameters, and so on, for all the different various ways that you can run Oracle databases. All right. Sorry. We also have a Prometheus exporter for Oracle, which will let you send database metrics out to Prometheus or any of those other things, like Splunk or whatever. They all understand Prometheus format. So it has some standard database metrics like processes and memory usage and weight classes and most commonly used statements and stuff like that. But you can write your own custom metrics. So basically anything you can write an SQL statement for, you can expose as a metric. So it could be application-specific stuff, like how many customers are in my table, or how many customers were created in the last one day, or whatever, stuff like that, right? You can expose those in Prometheus format so that you can build Grafana dashboards, or you can do the same thing with Splunk or Datadog or any of those other technologies in that space. It also exports the alert logs, which is, if you don't know what it is, don't worry about it. It's not important. If you do, that's an interesting thing. So the database tells you when bad stuff happens to it, in this special table. So it can pump that out into a file that gets updated all the time. So you can read it with a Promtail or a FluentD or something like that into your centralized logging system. It's highly optimized for minimum memory usage. I can tell you, I wrote it myself in Go, which is terrible. I know, I'm sorry about that. And let me tell you, I know way more about Go memory management than I ever wanted to know. Ever. It's crazy. You thought JVM was bad. You learn how Go does memory management. It's incredible. But this thing is super optimized. It uses a teeny weeny little bit of memory. And it has a bunch of pre-built dashboards for Grafana as well. So this is interesting. Like if you've got all your microservices and you're doing all your observability stuff with Grafana and Prometheus and whatever, you can also monitor the database and all the internals and stuff going on in there in exactly the same way. Okay, so you don't have to like have a completely separate system to monitor your databases. All right, woo, nearly there. All right, and it's 8 o'clock. We're doing good. All right, what's next? Virtual threads. You said virtual threads. Does anybody use virtual threads? All right, here's your homework. Go home tonight and use virtual threads. They're great. All right, if you haven't tried it yet, do it now. So these were introduced, I think, in JDK 17 as experimental, and their production in 21, I believe. Basically, what it is, in the olden days, before JDK 21, every thread in the JVM was mapped onto an operating system thread. Okay, and operating system threads are a limited resource. You may only have, I don't know, 10,000, let's say, for argument's sake, depending on your operating system and the user, the way it's set up and whatever. They're a finite resource. You use them all up, you're screwed. Your application stops, right? There's nothing you can do about it. And they're kind of slow because they're blocking all the time and all that, So virtual threads is basically a lightweight thread that is not mapped onto an operating system thread. They're sort of pooled. So when you need to use them, they do obviously grab a thread because they need a thread to execute, but then the threads are multiplexed, the operating system threads are multiplexed over the virtual threads. So you can do whatever you like. You can do a blocking call, without a care in the world. And you don't have to worry about it because you're not going to consume a thread. You're only using this virtual thread that doesn't really exist. It's just in a simulation, if you like. Doug and I just read this book about how we're living in a simulation, talking about it on the way here. So they can greatly improve performance of an application by literally doing nothing other than turning on virtual threads. Very often you'll see a massive improvement in performance. It could be that you process way more work with the same amount of resources, or it may be that you process the same amount of work that you were before, but you use way less resources to do it. And again, it's super cool. Like, it's one of these things you can go and do it. Like we did a demo actually at the Austin Java user group about a month ago, which I would be happy to do for you too if you're interested in. We built a system that's like collecting toll data as you drive through the toll gantry, and it sends in like your license, a picture of the car and your license plate and the ID of your toll thingy and all that sort of stuff. It calls an AI to check that, to look at the picture and work out what kind of car it is and what color, and make sure it matches the vehicle that's actually there and all that kind of stuff. And we did it, and it was like slow. It was like terrible slow. It processed like, I can't remember, 50 cars a second or something. And we did a bunch of stuff, including turning on virtual threads. In this, we walk through all these things in the demo of how can we improve the performance and so on. When we switched on virtual threads, it got like 100 times faster by doing like literally nothing other than just switching from OS threads to virtual threads, which was quite amazing. So I highly recommend checking it out if you haven't. And in Spring Boot 3, they added support for virtual threads. So Spring Boot 3 prereqs JDK 17 and also runs on everything later. In Spring Boot, you just add this to your application.properties or the equivalent thing to your YAML file. Spring threads virtual enable equals true. That's all you got to do, and your app will run with virtual threads instead of OS threads. And very often, literally just by doing that and nothing else, you will get a good performance boost. Maybe you'll save 30% of your resources, which Again, if you're running hundreds of these things and you're running them on a cloud and you're paying for the CPU and the memory and stuff, that's a big deal, right? You could save a lot of money. So the other thing, I don't want to offend anybody here. If anybody likes reactive, don't be offended. Reactive is, I don't like reactive. So, I always use like WebMVC and stuff in my Spring apps. I'm not a big fan of reactive. This will give you similar performance that you would get from reactive without having to deal with any of that flux and mono and all of that garbage, right? So, all right. And what talk can be complete without talking about AI? All right. So, the hottest project in Spring right now is called Spring AI. You'll be surprised to hear. And it allows you to do a bunch of stuff. Do people know about AI and LLMs?
Yeah.
Of course, everybody knows, right? So it lets you interact with models for doing embeddings and inferencing and summarization and all that kind of stuff. Lots of different models, OpenAI's models, Facebook's, Meta's models, so on. To manage prompts and prompt templates and to do prompt engineering and prompt tuning and stuff like that. Output parsing to build retrieval augmented generation systems using vector databases, to do document chunking, create vectors, perform vector similarity searches, blah, 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 all that stuff. Okay. That's what Spring AI is all about. One of the headline features in the new version of Oracle Database 23 AI, we changed it from C. We used to use C for cloud. We changed it to AI now, the version number. The 23 AI has a vector store, a vector data type. So in the database, you can say, create a table, blah, 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 and this column is a vector. And it understands the different kinds of vectors that you can create. It has the vector distance calculations like cosine distance and dot point and Euclidean and Manhattan and all that stuff built in. So you can do queries of the similarity between vectors, the semantic distance between different vectors. You can run Onyx models in the database itself. Now, the database does not yet support GPUs, only CPUs, so obviously that would be a lot slower than running the models on a GPU. But depending on what you're doing, like if you're doing embeddings for a chatbot, probably not a big deal. You're not going to be doing that many. You may as well just run it there and save yourself some money on the GPUs. We also have a GenAI service on Oracle Cloud, which does embedding and inferencing and so on. So we have contributed support for all of that stuff into Spring AI. So if you're interested in building projects using Spring AI, you will have access to Oracle as the vector store and for embeddings and inferencing and all that kind of stuff. Okay. We're also doing it for non-Spring frameworks like LangChain for J, for example. Not just for Spring AI, but obviously since the talk is about Spring, that's the one I'm highlighting. All right. You made it. Don't leave now. That's the last slide. All right. So that was a lot of stuff, I know. I went through a lot of different things that we're doing around Spring and the Spring ecosystem. Hopefully there was some stuff in there that you found interesting. I'm sure there was some stuff that you didn't know about Oracle. So if you want to learn more, that thing will take you to the main site for the Oracle Backend as a service, where you can find most of this other stuff, hanging off there. And that's it. That's all I have. Thank you.
Oh, wait, so I have a couple questions here. Is there a situation where you wouldn't want to use virtual threads? You'd want to use conventional OS-based threads?
Probably.
Can you name one or?
No.
No, okay. And I have another question.
Yeah.
You mentioned a Graal image doesn't actually run on the bare metal. Can you elaborate on that?
Technically, it runs on the on a VM that's called Substrate VM, which is a very low-level VM, very small, fast VM. So it's comparable to, if you build a Go application and you can build a binary, It's actually not really a binary. It's like an ELF binary. It's actually linked to glibc. Like you still got to have glibc,
Okay.
right? It's the same kind of thing. Like it's pretty much a binary, but there's still like this one little library. So you can't run it on like a from scratch,
Right. Okay.
right?
All right.
Same with Go. You can't. Well, I mean, in Go you can tell it not to link to glibc, but then you don't get any of the standard library or anything like that. So yeah, it's for all intents and purposes, most people wouldn't even know or care. It's essentially a
Well, come to
binary.
think of it, if you do what I did and tried to run a Graal image without glibc,
Yeah,
then
yeah,
you care.
you'd notice.
Yep, yep.
Yeah. Oh, I forgot to say too, Go has Go routines, which are virtual threads is basically the same thing as if people are familiar with Go. I had to use Go a lot because a lot of Kubernetes stuff is written in Go. So Java virtual threads is kind of copied from Go. No.
Anything else?
Michael, you want to take over here?
Sure.
All right.
Other questions? I asked on YouTube if anybody has any questions there, but nobody took me up
Okay.
on that.
I think you're.
Get them in front of the kids.
Yes, so
think your
I'm
slide
almost
is right.
ashamed to admit
There
that
you
I'm
go.
still running MySQL 5.6.17.
That's terrible.
And 8.4, I think, is the latest long-term support release, but one of these days I'll. No, it's
You're not using Java 8, are you?
no. I'm using JDK 22.
All right.
where I can- Yeah. Yeah. All right. So anyway, thank you very much for that. And if you have any questions, please, shout them out. And so just to wrap up, upcoming events, as I mentioned, InfoQ Dev Summit Boston, the 24th and 25th of this month at Boston University. There is a discount code for $100 off. Has anybody thought about being able to go? Okay, you got two. All right, then we don't have to raffle it off then. All right, beautiful. All right, so see me afterwards. All right. Okay, and then there's a Payara virtual conference on the 26th and 27th. And there's the URL right there. Yes, 2 days. I think this is focused more on security this time. The Kansas City Developer Conference is actually that same week. That's going to be a busy week in the end of this month. And that's always a fun conference. So that's the information right there. Dev2 Next, if anybody remembers Venkat Subramaniam, he's the one who runs this, and this is in Colorado at the end of September into October. So you can check that out. There's the Open Community Experience, formerly known as EclipseCon, at the end of October as well. This is in Germany, so if you want to go see, the my homeland, then definitely take a chance to go out there. So, and then QCon San Francisco is right before Thanksgiving. I'll be there as a dedicated reporter again, like I was last year. A lot of work, a lot of fun. And yeah, there's a lot of great talks at that event, right? So. Okay, this is all right. Upcoming events for us. Next month, Nehar Sardana, who's one of on the leadership team of the Garden State Jug, will be here to talk about Scala programming for Java developers, a beginner's guide. So Scala, for those you may not know, is a JVM language. It is definitely different. I've seen a bit of it. I haven't studied it too much. And then in September, we have chosen a topic for Marcus Hellberg from Baden who will be here. And it is building a custom chatbot with Spring Boot, React, and LangChain4j. So that should be fun. In October, we have Amol Gote to talk about digital signatures decoded, crafting an in-house e-signing microservices. That's October 8th. And originally, at DevNexus, Garrett said he would be in the United States at the end of October. However, that all changed. So he said it's most likely not going to happen, but if it does, so we still need to fill in time for November and December of this year. And so if you have burning desire to talk about something that might interest everybody, please let us know. The leadership team, info@gsjug.org. Oh yeah, this is Friends of GSJUG, the Boston Java Users Group, formerly the New England JUG, will have their meeting tomorrow night and also on Thursday night, and that's on the next slide. Then some guy named Michael Redlick will be at the New York Java SIG on Thursday, and I'll reprise my presentation on Jakarta E11, and I'll have some updates based on the specifications that recently passed their reviews. So that's in 2 days. Yes, it's at B. No, that's if you look there, Scott, it says Thursday, June 13th. Yes. Yes. So my challenge there is to drive Barry as crazy as possible because I normally like to walk around when I give a presentation. So
You will indeed
Yes.
drive me crazy.
but yeah, so that's on Thursday. I look forward to that. All these years is the first time I'm going to give a presentation at the New York Java SIG. So we'll have to commemorate that somehow. And let's see, this is, the Boston Java User Group again. They have a second meeting on the 13th as well, but everybody should come out to New York to see me. Sorry, a little ego shot there. And then Kansas City JUG on the 20th, we'll have Deshaun Carter and Brian Kelly to talk about what's new in Spring Boot 3.3. I copied that from their meetup page. It would be Spring Boot, not Spring Framework. That's 6 something. So yeah, I'll update that. And let's see. Yeah, all right. Importantly, if you have not signed in, please do so. I'll use that information who was here, and I'll run my random number generator, and I'll inform the winner who gets that copy of IntelliJ IDEA. So other than that, we look forward to seeing you on July 9th. And enjoy your summer. Hopefully you guys have nice summer plans, and enjoy. We'll see you next month.